Hello viewers, I remain Beatrice Christopher from Statistics Scribe. God willing, in these tutorials I'm going to show you how to perform one-way analysis of variance when you have a data frame. Okay, so quickly I'm going to create a simple data frame, all right, before performing the analysis of variance. So all you have to do is you can enter your data the way it appears. Okay, but this time around you define the variable for each factor. Okay, each factor now will become a variable in R. Okay, so all you have to do is you enter your data. Unlike the other method that we applied previously, you can check them. It's either you enter your data row wise, like this, or column wise, like this, like this, like this, or at random, right? So this time around I just want to create a data frame so you'd understand how to do that also, but it's a little bit tricky. Trust me, it's straightforward. So for the first variable here, we have site1 containing my data. You concatenate. We have 3, 4, as you can see, 3, 4, 2, 5, 2, 7 down to 21. 3, 4, 2, 5, 2, 7. Make sure you're entering the data correct. 3, 1, 2, 6, 3, 4, and 2, 1. Then you hit enter. You go to the next site, which is site 2. Next factor is site 2. Site 2, you concatenate. We have 3, 3, 3, 5 for site 2, 3, 1, 3, 1, 4, 2, 3, 3. These are the data I just entered now for site 2. Then for site 3, we have 17 down to 29. And all you have to do is hit your enter key. Site 3. For site 3, my assignment operator. Here you concatenate. Site 3, we have 17. We have 3, 0. We have 3, 0. We have 2, 6. We have 3, 2. We have 2, 8. We have 2, 6. And we have 2, 9. Then for site 4, assignment operator, concatenate. We have 2, 8 here. As you can see, after 2, 8, we have 3, 3, 3, 1, 2, 7, 3, 2, 3, 3, 4, 0. Okay, so after entering all the data you have in this manner, all you have to do is you tie them together. That's by concatenating them. So we are assuming that this is a data set on the yields of maize across different sites. Okay, so permit me to call this yields. My bad spelling. This is yields defined by, you concatenate, you tie them. The first yield we have is from site 1, so you say site 1. You don't have to put it in quotes because this time around you're calling the vector itself site 1, and the next one is site 2, site 3, and last but one, site 4. That's all. So what we did here is simply put, we actually enter the data column wise: 3, 4, 2, 5, 2, 7, 3, 1, 2, 6, 3, 4, 2, 1. That's what R will do. So it will enter this data first before taking the next order, which is site 2, 3, 3, 3, 5, which is this, followed in this order. Okay, I hope you understand what this concatenation means for each of this vector. All right, so quickly you hit enter. Remember, I'm using R Studio as an IDE for R. Okay, you can actually use R, and I'm using the R script here in place of the R console. Okay, you can use the R console if you want to, but I prefer using the R script for easy debugging. Okay, so we have yields here, which is our response variable, right? So the next thing you need to do is we have our factor here, and our factor is called site. So we have site 1, site 2, site 3, site 4, meaning we have 4 factors. So what to do here is you have site defined by, remember previously we defined our factors by using the as.factor function in the previous video on one-way analysis of variance to tell R that what we are citing is a factor. Okay, so another way of doing that is to use the rep function, okay, for replication or replicate. So now this time around I'm going to concatenate this. Now I'm going to use the rep function in the concatenation function. So I have rep open parenthesis. Remember, RStudio will always give you an open and close parenthesis or bracket, right? So rep, this time around, the first rep is for the first factor. So rep of what? Site 1. Now this time around, we are assuming this is just a nominal variable, a nomin variable, site 1, site 2, site 3, site 4, because we don't know which is better than which. So this time around, it's just a naming variable. It means it is a string, okay? Now string in this case means it to be in quotes, quote site 1, because it's just a factor, okay? So we have site 1, comma, then we have another function in the rep function called length. So this length will tell you the length of each variable. It will count. For example, for site 1 we have a length of 1 2 3 4 5 6 7. For site 2 we have a length of 1 2 3 4 5 6. For site 3 we have 17, this, okay? It counts. For site 4 we have 1 2 3 4 5 6 7. Okay, so this is just all what it will do, but you don't have to write it, because should you have a data set containing a column with like 3 million data, would you be counting it this way? No, the computer will do that for you. So all you have to do is length of which vector. Because it's a vector at this point in time, you won't put it in quotes, you have to put it exactly the way it is. So site 1, okay? So you're done. Now you go out here, put a comma. Remember, the last parenthesis or bracket here is for the concatenation, right? So put a comma, repeat the same procedure. So it means with or without space here. Take note, with or without space here is, it will still give you the same result, okay? So rep function, the same thing, quote for site 2, right? Then you go out again, comma, then length function, length of what? Site 2, in that order. That's how you'll do it all through until you get to the last one. Rep of site 3, okay? Go out, then comma, then length of what? Site 3, okay? Out, comma. Permit me to expand it so you see this clearly, okay? Let me expand this by maximizing. Then we have rep again, open parenthesis, quote, site 4, out, comma, right? All you have to do now is we have a length function, my bad, open parenthesis, site 4, right? That's all for that. All you have to do now is hit your enter key on your keyboard, okay? So we've entered our response variable, which is yields, and our factor, which is site, okay? The next thing you have to do is, we know we are talking about data on the yields of maize across different sites. So now this time around, I want to create a data frame now. Since we are applying the data frame approach, I want to create a data frame on the maize itself. So maize defined by, now the function for data frame is data.frame. So I have data.frame, open bracket, data.frame of what? What's our response variable? Our response variable is yields. So we have yields, my bad, wrong line of code, line code 7, yields, right? Then our factor is site. So we have yields and site. That's yields comma site. Then you press your enter key. Next thing is we need to perform the analysis of variance, and the function we want to use is AOV and Anova. So I want to contain the AOV function in a variable called analysis for easy understanding and readability. So I have analysis, you can call it anything you want to call it, as a variable containing the AOV function. So AOV open bracket, analysis of variance of what? What's our response variable? Yields, then your tilde sign, yields on the factor, which is site, then comma. Now we have to call the data, okay, since it's a data frame. Now to call that, you have to check the data.frame function is saved in what? Maize. So it means we have data equals maize. Remember, R is case sensitive, okay? Then enter. The last thing you need to do when you're done with all this is to use the Anova function to get your output, okay? So we have Anova of what? The AOV function. So the AOV function, we saved it as what? Analysis. So it will be Anova of analysis. Okay, spelling error, my bad. So once you're done with that, all you have to do is you run your analysis. Okay, but I deliberately made some errors so that you'd see how to debug. Okay, so should you not make any error, that's fine, that's what I want, but I did this deliberately so that some of us could see, because I know some might have problems. So but should you have problem that's beyond you, you can actually reply us on the comment section. Okay, so all you have to do is you run your code. So let's say I want to run everything, command enter or control enter depending on the machine you're using. See, I have error, I have object site 4 not found. Okay, so site 4 is not found, the object. Observe all the objects, site 1, site 2, site 3, site here. So this is supposed to be site 4. This is not just the only error, but sometimes if you're not careful, you will have a wrong output. I'm going to show you an error also here. So let me shift here so you'd see, navigate through, see site 3 length, site 3 replication, site 3 length, site 4. See here, the replication is showing site 3 length of site 4. We already have replication for site 3. Here is supposed to be site 4. Okay, length of site 4. But let's assume you made such mistake. Observe what will happen. Your output will be wrong. So I'm trying to show you how to run away from making errors. So let me run my selections. So it did not give me any error code, as you can see. So you are having the wrong output. This is actually wrong. Okay, so let me show you why this is wrong. Now, because our site is not right for the replication 4. Okay, observe, I'm going to correct that. So quickly come here to where we have that. Let me go there, navigate easily. So this is the place here. This is site 3 length. Site 3 is supposed to be site 4. Okay, so observe now, the table will change. That's why I did that, so that some of us that usually make mistake running the wrong analysis will know how to fix it. Okay, so quickly run my selections. Observe now, check. This is my degrees of freedom. In the wrong one, it's showing me site 2. Remember, we have 4 sites. 1, 2, 3, 4. It's supposed to be 4 minus 1, which is 3. Observe, this is the correct one. So sometimes you can get the error yourself when you have the basics of analysis of variance. Okay, you know that the degrees of freedom for every treatment is always number of treatments minus 1, and here we have 4 treatments, which is our sites, right? 4 minus 1 is 3. This is already wrong, so obviously the data in the outputs is also wrong. Okay, so that's why I showed you how to debug here. So this is the correct output here, as you can see. Okay, so now let me clear off everything. Now I'm assuming for some of us that entered our data correctly, you'll have something like this, exactly with no error. Okay, so if you have something exactly with no error, all you have to do is you run your line of code. That's all. So you run it, fine. This is our output. You can expand it if you like. You can use the run here. After selecting it, you still get the output. Can you see it? Okay, also when you have so many lines of codes and you don't want to select all, maybe you just want to select a portion, all you have to do is the last function. All you need to do is select the function that will make your analysis to work. For example, we have Anova here, so we can select only this. Why? Because selecting this will run for analysis, and analysis will not just run because it requires AOV, and AOV is a function of yields and sites. So invariably Anova depends on analysis, analysis depends on AOV function, AOV function depends on yields and sites. So it means it will cover up everything. Okay, and site itself depends on the replication of site 1 and its length. Okay, and the yields also depends on site 1, site 2. So invariably you can just use the Anova here alone. So this is what I'm going to do. I'm going to select this. I'm showing you that you can actually do this, then you run it. Okay, so once you run it, you get your feedback back. So I hope you like this video. Kindly like, share, subscribe, hit on the notification bell for more updates. Okay, thank you for watching.